Alright, nerds, let's get started. At this point, you know radiation is simply particles that are separated from high-energy, unstable nuclei. Grab a highlighter. For example, alpha particles are 2 protons and 2 neutrons that are separated from a large, unstable nucleus. Okay? So we know that alpha particles are 2 protons, 2 neutrons that are separated from large, unstable nucleuses. A beta particle is an electron that's emitted. Beta particle is an electron that is emitted from an unstable nucleus. This happens when a neutron in the nucleus turns into a proton. Finally, you know that gamma radiation isn't a particle at all. Gamma radiation isn't a particle, but rather a form of energy that leaves the nucleus. It's a form of energy. Now we have to think about the changes that occur when these type of radiation leave different nuclei. Think about it. If we have an atom that loses an alpha particle, okay? So if we're losing an alpha particle, it changes that type of atom. For example, uranium, number 92, if we lose 2 protons and 2 neutrons, we're going to become thorium, number 90. And our mass will go down by 4 as well. It lost 2 protons and 2 neutrons. On the other hand, if uranium were to give off gamma radiation, it would not change at all. This is because gamma radiation are not particles, but rather energy, similar to how light is just energy. Gamma rays do not contain protons, neutrons, or electrons. Therefore, when a gamma ray leaves the nucleus of uranium, it does not change uranium into any other element. What will uranium turn into if it emitted a beta particle? Okay? So if we emit a beta particle, that means we're going to get rid of an electron, but it also means that a neutron will turn into a proton. So our mass number won't change, but the number of protons will go up by 1. So if we're looking at, you will need your periodic table for this. If one of our neutrons turns into bloop, a proton, our 92 becomes 93, and we are now Neptunium. Okay? All right, so let's do these first 3 on the front, and then I'm going to have you finish some of the ones on the back. Uranium, we just talked about, emits gamma radiation. Fill out your table below. So we're going to emit some gamma radiation. Woo! Okay? Over here we have to have our symbol of the element after radiation. Okay? So we know that uranium is U. Find it on the periodic table. Our number of protons is 92. And our mass number rounded is 238. Okay? Let's do radon. Radon emits an alpha particle. Fill out the table below. So if we're losing an alpha particle, alpha particles, as we said from the top, are 2 protons and 2 neutrons. Let's color code this. So we're going to do, based on how highlighted at the top, my blues are going to be protons. My pinks are going to be neutrons. And my yellows are going to be electrons. You have to have 3 colors. Okay? Any 3 colors is fine. They don't have to be the same as these. Okay? So we're going to emit two protons and 2 neutrons, changing this atom. Okay? So first off, we need to know what radon is. Okay? So we're looking for Rn, radon. Okay? Find on the periodic table. Hint, it's a noble gas. Alright, we should have been able to find it down here. Radon number 86, mass of 222. Okay? So we're going to put on here, this was Rn, 222 mass, 86. Okay? So now, we're going to lose 2 protons, 2 neutrons. So our top number goes down by 4, and our bottom number goes down by 2. Okay, so now over here, first we have a new element. And actually, we're going to draw it. Yeah. Got my two colors. Bam, 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 bam. And we now need to say over here what this element is. Okay? So here's my new element. I got to figure out what happened when I lost an alpha particle. This guy here, that's my alpha particle. Okay? So now this guy, we got to take this number and go down by 2. 86. We are now polonium. Okay? So our symbol is now PO. Our atomic number is 84. We're not using this mass. Okay? We were radon 222. We lost 2 protons. We also lost 2 neutrons. So we subtract 4 from this number. Okay? Because remember, 222 includes our 86 protons and however many neutrons we have. Okay? So this ends up being 218. Okay? Polonium on here normally has a mass of 209. Okay? But we're not using that because this one went alpha decay. So we just subtract 4 from radon. Okay? So this is our symbol of this guy after alpha decay. Alright? Alright, let's try beta decay. Okay? So now we have plutonium. Okay? Go ahead, find plutonium. It's in the last row, very bottom of your periodic table, not far from uranium. Bloop. Alright, plutonium, 242 and 94. Okay? So this guy is Pu, 242, 94. Okay? And we're going to lose a beta particle. Okay? Now if we lose a beta particle, it's going to basically shoot out an electron. Okay? I'm going to make a little E here, negative charge. Okay? Now at the same time, in our nucleus, it's not getting rid of it, so we're going to do this. One of our, make sure we say this right, one of our neutrons turns into a proton. Okay? So one of our pink guys turns into a blue guy, but it stays right inside. We're not going to leave that nucleus. It's going right back in there. Okay? So one of our neutrons turns into a proton. Okay? So that means now this number is going up. 94 becomes 95. Okay? Because these were both mass and they had a mass of 1, our top number is not changing. Okay? So this is still 242. Okay? So now looking at our group back here, we went up 1. This is now americium. Okay? Symbol AM. Okay? Our mass is not 243. It's still 242 because our mass does not change. Simply one of these transferred over into, one of our neutrons transferred into a proton. So our mass stays the same. Okay? So here's how we're going to be doing gamma. Here's how we're going to be doing alpha. And here's how we do beta radiation. Okay? You got another alpha and beta to do on the back. Make sure you're using colors. Okay? Let's do one of our equations on the back. And then I want you guys to finish this out. Number 6, when uranium decays and emits an alpha particle, what does it become? Okay, so we're going to write out our chemical equation using symbols and our mass numbers. Okay, so we have uranium. And uranium, okay, is 92 and 238. Okay, and it emits an alpha particle. Okay, so basically we're going to lose an alpha particle. An alpha particle has 2 protons and 2 neutrons. Okay, so 2 protons, 2 neutrons, so it has a mass of 4. And we just write it as He. So that's how you would write out that. Okay, and then what we equal, so once we get rid of our alpha particle, we then turn into 90, 238 minus 4 would be 234. And 90 we know is thorium, TH. Okay? Let's do a beta particle. Okay? So we have francium. Okay? Francium is one of your alkali metals. Okay? So what's our atomic number for it? Okay? It's going to emit a beta particle. Okay? You can write this two ways. You can write, we're going to emit a beta. We'll just write out the word beta. You could also subtract an electron from it. Okay? So if we subtract a beta particle, what you're then going to become, we're going to lose an electron, and then 87, we go down one. One of our neutrons becomes a proton. Okay? So because one of our neutrons turns into a proton, 87 goes up 1. So we go bloop, turns into 88. Top numbers for beta radiation never change. So we are still 233. Because we went up by one number, we are now radium, Ra. Okay? 87 went up by 1 to 88. Okay? And we have one electron. Okay? Electrons don't have any protons, and they don't have a mass. So our two numbers there are 0, 0. Okay? Go ahead, finish out the rest. Remember, gamma radiation doesn't change at all. Gamma radiation, our symbol for that, you can write down as gamma. Looks like that. Okay? Go ahead, and you're all set.